Cool. Now let's look at the last question here. And we see that the structure is dan.barkPim. And where Dan is our calling object, bark is our method, and pim is our parameter object. And so now before I jump into this problem, I do want to say that if you've tried this on your own and were a little confused by the solution, there is a common misconception that many students make when approaching this problem that I will cover, and hopefully that will clarify things for you. And so let's just start by doing our typical process. So our static method, our static type of Dan is dog. Our dynamic type of Dan is poodle. Let's just change color here. So poodle. The static type of pim, which is our parameter object, is poodle. Cool. So now that we have that out of the way, let's move on to compile time, checking whether it would actually compile. And so let's write down what we've been doing so far, just the static types of each of these, the calling object and the parameter object. So dog.bark, and it takes in an object of type poodle. Cool. So now when we get here, this is where the misconception typically happens. We look at our dog class over here. We check our methods. We're trying to find a bark that takes in an object of type poodle, and we see here, oh wait, there's only a bark that takes in an object of type dog. So maybe this should be a compile time error. The thing is, there is a special rule here that comes into play in this problem, and we haven't really seen it before, which is why it's super easy to get tripped up. But the rule is that since a poodle technically is a dog, you can actually use this bark method listed here and lock that in as your method. And so it will not have a compile time error. And to clarify this a little further, a poodle is a relationship with dog. And the reasoning for that is because here we see that a poodle extends dog, and therefore poodle is a subclass of dog. And so since a poodle is a dog, if you want to call the bark method with an object that is a poodle, you can also call bark with dog, because all poodles are dogs, and therefore anything that you pass in as a dog can also be a poodle. And so that's why that works, because dog encompasses poodle, and therefore the bark method of dog should also be able to cover the bark, like the poodle will work in this case since it has and is a relationship. If this were the other way around, just to give you an example, I don't want to confuse you further, but let's just write a small example out here. Like if I wanted to do dog, oh, that color is really hard to read. Let me choose a better color. Dog dot bark. Let's say I had dog dot bark dog. And the method here was poodle, so it only took in poodle. Now this would not work, because if I were to pass in a dog, here, if I need to find a method that takes in a dog and I only have a method that takes in poodle up here, since a dog is not a poodle, there are several types of dogs and poodle is one of them. But if you have a poodle, like that doesn't necessarily encompass all types of dogs. So if I were to write out like dog, poodle is in here, right, in the small bubble. And so that wouldn't work because it doesn't have an is a relationship. And so, yeah, this would not work if the class here, inside the class, the method had been defined with a poodle. It only works if the thing that you're trying to call, like the parameter object, has and is a relationship with the actual object that has been passed in as a parameter object within this class. Hopefully that made sense. If it didn't, definitely follow up with more questions by asking your CSM mentor over email or at your next section. It is a confusing topic, and it is definitely understandable if you do need some more examples or more time to digest this. Cool. So now we're gonna actually call the dog.barkDog method. And this is gonna work. It's gonna compile, and I'm going to lock in dog.barkDog. So I'm not gonna use poodle here. I'm gonna use this. Cool. And so now when I go to runtime, I'm going to put this down as my default. But I'm also going to check my dynamic type first to see whether I can use that. So I'm going to do poodle.bark dog. Cool. And so now I can go to my poodle. Does it have a .bark dog? So I go to my poodle class here. Does it have a dot? Yes. And then I print out woof. So now before I move on, I do want to say that there's another thing that happens here, like another common misconception here. So many people think that it'll actually print out yap. And the reason for this is because they say, well, since I originally wanted to pass in poodle as my static type, I'm going to actually do poodle.bark poodle. Because I get that it compiles in my compile time with this dog method, but since I do want to use poodle anyways, I'm going to just pass in poodle. And this does not work. The reason for this is because when you find the static types at compile time, you're locking it in. So whatever you decide on in compile time as like with your static types, those are the types that you're locking in for the rest of the function. That's what you're locking in for compile time. So think of it as this part of this that you've written down in your compile time cannot be changed. It's unerasable. You wrote it in pen, well, not erasable pen, and so it can't be changed. So when you bring it down here, the only thing that can be changed down here is this part, which is the calling object. But the type of the parameter object is locked in at compile time, and so that's why you have to call poodle's bark method that takes in the parameter with type dog and not with type poodle, because you really, after you decide on compile time to compile with this dog, since it would have an error if you tried to compile with poodle, since there is no like specific poodle, you're just gonna decide to use that in your runtime as well, and you're gonna print out woof. So yeah, again, hopefully that made sense, and if you have any questions, definitely follow up. But with that, that's the end of this 3.2 walkthrough. Hopefully that was helpful. And in the future, if you notice that any problems on the worksheets are difficult, or if you think you need a walkthrough on those, definitely reach out to your mentor and let them know. Cool. Bye, everyone.